Let's try another example. So here's our graph of the first derivative. We're going to start with step 1. Make a first derivative number line by using this graph. And remember, this number line just comes straight from this graph, not the slopes, just from this graph. So this is negative is below the axis, positive is above the axis. So it looks like I've got a critical number at -2. And to the left of -2, I'm negative below the x-axis. To the right of -2, I'm positive above the x-axis. And that's my number line from this graph. Negative below, positive above. Just taking this graph and turning it into this number line. Now for the second derivative, let's look at the slopes of the first derivative. So it looks like this whole time I've got a bunch of positive slopes. This whole thing. So it's all positive slopes. However, one thing to note, I have a sharp turn there. So if I have a sharp turn, does the derivative exist? No. So at 0, it looks like I have a hole because the derivative isn't going to exist there. It's a sharp turn. However, to either side, it is positive because increasing, increasing, all positive slopes. Okay, next, let's use these two number lines, sketch a possible f. So now that I'm looking at the original, this negative means decreasing, this positive means increasing. So decreasing, increasing, and both of these should be concave up. Okay, so let's go left of -2. I should have some decreasing happening. Right of -2, I should have some increasing happening. And it should all be concave up the entire time. So let's see. Concave up for decreasing, concave up for increasing. Something like that. Now, we do know right here that we need to be careful because right here f prime exists because there's no hole on the f prime graph, but f double prime does not exist because it's a sharp turn. So these fit together right here, but the left equation would be different from the right equation. They fit together for the first derivative, but not the second. So we've got something like this. Now, it does also ask us to sketch a possible graph of f double prime, that's what I meant to say, of the second derivative. So remember, the second derivative would be the slopes of the first derivative. So let's look at the first derivative and check out the slopes. So it looks like up to 0, this slope is all the same. Rise 1, run 1. So m equals 1. So left of 0, this slope is all going to be at 1. Now I start to estimate some stuff. So let's do at 0 right here. Tangent line, that would be, looks like m equals 0. So at 0, the slope is 0. And let's do another point here. Do this tangent line. That looks like a slope of rise 2, run 1. So this is at 1. So at 1, the slope is 2. 1, the slope is 2. And I can start to connect these to get the slope, or the graph of the second derivative. And I know that I've got holes right here because the second derivative doesn't exist. So that's it for lesson 5.2. You should be able to get started on your assignment now.